Good morning. Welcome to the Lionheart Academy. This is Richard Tai. Today we're continuing our trigonometry lesson. Today's lesson number 40. We have spent a lot of time on fundamental relations already for the previous 4 lessons. Now today we're going to try to look at some more examples of how to verify trig identities. Okay, I felt that we probably need to look at some more examples so that people can look at the different skills and different techniques that we can use to simplify different trig identities. Okay, so let's go ahead and try a problem here to start with. Let's go ahead and do this 1 plus tangent square theta divided by 1 plus cotangent square theta equal to tangent square theta. Okay, so when we are starting to deal with fractions, there will be lots of fractions that we have to deal with. So it's important for you to understand how to work with fractions, how to multiply and divide fractions, common denominator, and things like that. All right, first of all, we see this actually. Look at the left hand side here. We probably want to start with the left hand side. I see 1 plus tangent square theta. I see 1 plus cotangent square theta. Now, if you go back to your formula sheets, you could go back to look at your identities. You can see that this is your Pythagorean identity. So that's secant square theta, and 1 plus cotangent square theta is cosecant square theta. Okay. Okay, I forgot to draw a line here just to separate them. Alright, so secant square theta and cosecant square theta, and both of them can be written as sine cosine. Remember? So secant is 1 over cosine. So secant square is 1 over cosine square. Cosecant square is 1 over sine square. And then remember what happens when you divide by fractions. When you divide by fractions, you multiply by its reciprocal, right? So 1 over cosine, 1 over cosine square, I'm gonna multiply by the reciprocal of the denominator, which is going to be sine square over 1, and then I would have sine square over cosine square. But sine square over cosine square is exactly what the definition is for tangent theta. So we proved that the two sides are the same. Okay, let me move it back up a little bit here. Yeah, so you can see the whole thing. Okay, so this is one example involving fractions. Alright, let's try the next example here. I'm going to use left hand side here. 1 over sine theta minus sine theta equal to cosine theta divided by tangent theta. Okay. So 1 over sine theta, let's go ahead and convert sine theta to be sine theta over 1. Now on the right hand side, I actually don't want to do much about the right hand side, so let me go ahead and draw a line here. But I do like to start off on the left hand side because the left hand side looks more complicated, and I think we can combine the fractions. But how do we add and subtract fractions? Well, we have to have a common denominator. So look at the denominator. You have sine theta and you have 1, right? So the common denominator is their multiple, which is sine theta times 1, which is sine theta. So that means for this fraction here, I need to multiply by sine theta in order for the denominator to become have a sine theta, so that we can combine them. So this becomes 1 minus sine square theta, sine times sine square, okay, divide by sine theta, and then 1 minus sine square theta is cosine square theta by Pythagorean identity. Alright, cosine over sine. Okay, now this looks very close to what we have here, but it's not quite there, right? We have cosine over tangent, but we have cosine square over sine. So how do we do that? Well, if you recognize cosine square theta is cosine times cosine divided by sine, right? Okay, and remember cosine divided by sine is cotangent, but also it is the reciprocal of tangent. So this can be written as this, because cosine over sine is cotangent, but cotangent is reciprocal of what? Tangent. So it's 1 over tangent. So now we can go ahead and write it in this form. Okay. Now, one thing maybe I have not made myself clear is that I have not explained clearly is why do we have to do this? Why do we have to convert one trig expression to another? To prove trig identities, to verify trig identities is very important. Later on in different kind of mathematics courses later and in different fields. So example, like when you're dealing with electricity, radio, heat conduction, and engineering in general. Because the reason is it's frequently necessary to change one expression involving trigonometry functions to another form more suitable for the situation and for that particular purpose at that time. And so in calculus, and you may have to do trig transformations, you have to do different things. You may be able to recognize one form is not going to work, and so you have to go ahead and convert to another form. So this skill will help us, will allow us to practice and to get ready for what's coming afterwards. So what's coming in the later in your later mathematical career. So that's why we need to practice improving identities, and it will help us develop, help us see what we can do. Because if we're comfortable with this, then we are not going to be intimidated by this trigonometry expressions later on, and so we can do trigonometry transformations. So now this is not exactly the same as an equation, because it doesn't really work like an equation. It's actually identity means that the left hand side is equal to the right hand side. Well, essentially it's kind of like equation, but it's a little bit different. Okay, now next lesson, so we're going to be talking about solving trig equations, so we'll see how that difference. But right now we're just practicing how to prove identities, how to transform one expression into another. Okay, alright, so let's go ahead and try example number 3 here. Let's try another one. Okay, I'm gonna pick out a few here today. There are more problems like this that you can try. It can be found on my website. Okay, it's on page 192 of the plain geometry textbook that I'm using. It has a lot of practice, and which is good. I think you all should go ahead and try to practice on your own. Alright, so sine theta minus 1 divided by cosine theta. Now this one actually is quite straightforward, because this is a fraction, but it has actually two parts, and because both of them has the same denominator, I can separate the left hand side into two fractions. This is another common technique just to separate the fractions. Okay, so we separate sine minus theta minus 1 divided by cosine into sine theta divided by cosine minus 1 divided by cosine. And as you can see, sine divided by cosine is simply tangent, and 1 over cosine is simply secant. So that was a very straightforward problem. Okay, alright, let's look at another example here. Okay, let's try this first. I think we've done something similar to this, but I do want to show you because this comes up quite frequently in problems. So I think you will see this again over again. So 1 plus sine over a divided by cosine a equal to cosine a divided by 1 minus sine a. So both sides looks very similar. Now one thing we can do is we recognize that cosine and sine, remember cosine squared a plus sine squared a equal to 1, right? And so cosine squared a is equal to 1 minus sine squared a. And so the key here is you recognize 1 plus sine a. Okay, if I go ahead and multiply by 1 minus sine a, that will give me 1 minus sine squared a. Okay, so that is going to be a very important key, that you recognize those are factors that can turn into our favor, because when I do 1 plus sine a times 1 minus sine a, it will give us 1 minus sine squared a, and 1 minus sine squared a is cosine squared a, okay, which we're going to write in the next step. So 1 minus sine squared a is cosine squared a, okay, divided by cosine a times 1 minus sine a, and then cosine squared a divided by cosine a is cosine a, and divided by 1 minus sine a. Okay, so we have proved this time you can transform the left to the right. Okay, that they are equivalent. Alright, so here the key was to recognize the factors. Okay, you understand that cosine squared a can be 1 minus sine squared a can be factored into 1 plus sine a and 1 minus sine a. That's often very much used in different kind of identities. Alright, so let's try another example here. 1 minus 2 cosine squared a divided by sine A, cosine A. Let's use alpha, okay? Alpha, sine alpha, cosine alpha, and it's going to be equal to tangent alpha minus cotangent alpha. Alright, so how do we approach this problem? Well, I'm tempted to go ahead and try to factor this, but if it's 1 minus cosine square A, it's going to be easy, right? We just convert that to sine square A. But we have two of them. Well, if we have two of them, we could do this. We could write it like this, can we? Right? Because 2 is just what? 1 minus 2 cosine square alpha. I can separate them, right? I can separate them into two things. Okay, so the denominator is sine alpha and cosine alpha. That doesn't change. So, but this becomes what? Sine square alpha minus cosine square alpha. Okay, sine square alpha minus sine square alpha. That's okay. Let's see what can we do with that, because now we can actually separate this into two fractions. Remember what we did? We did that similar method. We separate them into two fractions. Okay, so it becomes like this. So sine square alpha divided by sine over cosine. Now you see, one of the sine cancels out. And then here, one of the cosine cancels out, right? So now it becomes sine over cosine, which is tangent. This becomes cosine over sine, which is cotangent. And so that is how we can transform this into that. So in calculus, one application in calculus is that when we want to integrate this expression is very difficult to integrate if you want to look at it or take the derivative of. But if you transform to tangent alpha minus cotangent alpha, it is much easier. It's so simple to integrate. It will be this is very easy to do. So that's why there's one reason that we have to do transformations. Okay, trigonometry. We have basically, so what we're practicing here is we're practicing how to transform one trigonometry expression to another for different kind of application and for different purposes. Okay, there are let's go ahead and try just a few more example here. I couldn't I don't think I have time. We have time to do all the problems, but there are some general techniques, and hopefully the purpose is that you can see the pattern. You can see something that we can always use, some techniques we can always use that will come up over and over again. And the key is there's no general approach, but there are some general techniques and the methods. So once you become familiar with this, once you do more examples, you should be able to approach them, try different things, and then not everything you try the first time will work. If it doesn't work, don't give up. Okay, just go back and try again. Sometimes I have to try several times. Right, let's take a look at this. Cosine theta divided by cosine theta minus sine theta equal to 1 over 1 minus tangent theta. Now sometimes you can do transformations on both sides to make sure that it works. For example, let's go ahead and actually deal with the left hand side. Now why do I have to do the right hand side? Why do I want to start with the right hand side? Because I know one tangent is sine over cosine, right? Okay, and okay, now I have a complex fraction, and then to get rid of the complex fraction, I need to multiply the numerator and denominator by the denominator. In this case, it's cosine, so I'll just go ahead and simply multiply them by cosine. Okay, so this one will be cosine theta divided by cosine times 1 is cosine, and cosine times sine over cosine, the cosine cancel out, so what's left is sine. So this is equal to that. So in this case, I actually transform the more simplified version to the more complicated version. But here, if you want to divide everything by cosine, you see, because you can see the pattern, right? There's cosine theta divided by cosine theta minus 1. You see here's 1 over 1 minus tangent. So if I multiply everything here by 1 over cosine theta, I will get this. Okay, so that's one way to look at it. There's always different methods to get to the same result. Alright, let's try another one. Example number 7 here. 1 plus secant phi plus tangent phi equal to secant phi minus tangent phi. How does that come about? Okay, let's take a look at how we can go ahead and prove this one. Okay, Alright, so let's start with this 1 plus secant phi plus tangent phi. One way we can do this is convert them to in terms of 1 over cosine and sine over cosine. Okay, that's always a good idea. So now we can combine the expressions. Now we can combine, or actually, let's go ahead because everything has to do with cosine, right? Well, if we combine them, let's see what happens. Okay, let's see what happens if we combine them. So it's 1 over 1 plus sine phi over cosine phi. Okay, so this is a fraction within a fraction, a complex fraction. And when you have complex fractions, when you divide 1 over this, is the reciprocal of that. So this simply becomes cosine phi over 1 plus sine phi. Okay, cosine phi and 1 plus sine phi, but that is not, excuse me, that is not what we want to go, right? We want to get into secant minus tangent. Alright, now what if I go ahead and multiply this everything by let's see, 1 divided by, I have to think about this. Give me a minute here. Let's think, what can we do? Okay, I think I see the 1 plus theta phi here, sine phi here. That can be a clue. Okay, so what we can do is we can multiply 1 plus sine phi by its conjugate here, which is 1 minus sine phi. Remember that guy? So now why do I want to do that? Because when you multiply by 1 plus minus sine phi, it will create a square. So this it will create a perfect difference of squares. It will be 1 minus sine square phi. Okay, and that will become cosine phi, cosine square phi, I'm sorry. So this becomes cosine square phi, 1 minus sine phi. Okay, and look at this now, cosine divided by cosine square phi, I can cancel out 1 cosine. Okay, so okay, this is dragging on a little bit long, but this becomes 1 minus sine phi divided by cosine phi. Okay, now I can separate them into 2 fractions, 1 over cosine phi minus sine over cosine phi. And so that would be equal to 1 over cosine will be equal to secant phi, and then sine over cosine will be equal to tangent phi. Okay, so that's it. Alright, so this one, it takes a little bit of work. Now I know, but this is probably not the only way to do it. I'm sure if you go ahead and try to do some other way, you can go ahead and do that. Okay, alright, so just want to show you the whole process. So this is a little bit more involved, probably not as familiar with this, so that's why we need to think about this a little bit. So sometimes it does take a while to come up with that. Okay, so let's try another one just to show you different kind of things that can happen here. 1 plus sine alpha times secant alpha minus tangent alpha, okay, equal to cosine alpha. Alright, so this problem actually requires just to use algebraic techniques to go ahead to do the multiplication here. So let's go ahead and just multiply and we'll see what happens. Okay, now 1 times secant is secant alpha, right? 1 times minus tangent is minus tangent alpha. Sine times secant, so sine times secant is actually plus sine times secant, but secant is 1 over cosine, so it's sine over cosine, so it's actually tangent. And then sine times tangent is sine square alpha over cosine alpha. Okay, so you can see tangent minus tangent cancels out. Okay, good. So that takes care of one problem for us. Alright, but secant is 1 over cosine alpha minus sine square alpha divided by cosine alpha. So 1 minus sine square alpha over cosine alpha, and 1 minus sine square alpha is equal to cosine square alpha. So cosine square alpha divided by cosine alpha is equal to 1 cosine alpha. Okay, so that's good. Now let's try one last problem here. Just want to show you another different ways that things can come about, especially using algebraic techniques. 1 minus secant square beta plus secant square beta tangent square beta, okay, equal to tangent to the 4th power beta. Alright, so it looks like a little bit complicated here from the first moment, but now let's remember there are several secant squares things that are going on here. Now remember, what is secant square equal to? Secant square equal to 1 plus tangent squared theta, right? So 1 minus 1 plus tangent squared beta plus secant squared beta. Let's go ahead and convert that to 1 plus tangent squared beta. So we have everything in tangent squares, okay? Because our answer is in tangent. So let's go ahead and do that. So 1 minus 1, let's open up this parenthesis. 1 minus tangent square beta plus 1 plus tangent square beta. Oh, I forgot to distribute this. Okay, so hold on. Distribute the tangent square beta, so it's plus tangent square beta plus tangent to the 4th power beta. Okay, now as you can see, 1 minus 1 is 0. Negative tangent square beta plus tangent square beta cancels out, so tangent 4th beta is equal to tangent 4th beta. So this one is actually quite easy. You just need to open up the parentheses, but of course use Pythagorean identities, convert secant square beta to 1 plus tangent square beta, and then just open up the parentheses. Okay. Alright, I think that's enough for today. Next lesson, we're going to talk about how to solve trigonometry equations. Alright, so if you have any questions and comments, please leave your question and comments in the comment section. Please also remember to subscribe and share on Facebook, anything. Share the videos with your friends and classmates, and hopefully this has been a help to you. And then we have been doing this for a while now. This is our 40th lesson, so we'll continue to go on to different trigonometry topics. So it will probably take us maybe a few more videos before we can finish the trigonometry lessons. Then we'll go on to address pre-calculus topics as well. Okay, so we can go ahead and see you join us in our next lessons. All right, thank you.